This is the video lecture for Math 3, Unit 4, Objective 2, and we're going to be looking at multiplying and dividing rational expressions. And just a reminder, rational expressions, again, are just working with fractions, right? So polynomial in the numerator, polynomial in the denominator, and that's what a rational expression is. So just a couple of things to remember. That they work the same as if you were working with just normal fractions, like 1/2, 2/3, that sort of thing. And so if we have two fractions here, and we need to make sure that b and d do not equal 0, because remember those are excluded values, right? Not in the domain of our polynomial expression in the denominator. So you would just multiply straight across, right? So a times c, and then b times d, and then that would give us our new created fraction. Okay. All right, so let's take a look at our steps. So our very first step, just like the last objective, is we have to completely factor, right? We have to completely factor the numerator and the denominator. And the three types of factors that we're going to be working with mostly is greatest common factoring, trinomial, difference of squares. We'll also be doing a cubic pattern. So if you don't remember that cubic pattern, you might want to go back and review that from a couple units ago. So if you are having something like a cubed plus b cubed, just a reminder that would be a plus b, and then a squared minus ab plus b squared. And then if it was a subtraction, then these two would be different, right? Okay. So this was SOAP, I don't know if you remember that, so that would be this is the same sign, so if that's an addition, that'll stay addition, so if it was subtraction, it would be subtraction, and then this one is opposite, and then the last one is always positive, and then your factors are always a binomial, and that binomial comes from the cube roots of both of those, and then you square the first root, multiply the roots together, and then square the second root, okay? So factoring is going to be key here. So if you're a little rusty on your factoring, you might want to go back and kind of review that. Okay. So our first step here will always be to factor everything. Okay. So we're going to just be doing a lot of factoring here. Okay. So this is 4x plus 8. So the very first thing I want to do is look for GCF. So I can see I can divide a 4 out of both of those, right? So that would be 4 and then x plus 2. Okay, so again, if you're rusty on the factoring, maybe go back and review one of those videos. And then in the denominator here, I can factor, let's see what divides out of 6 and 10. So I know for sure at least a 2. Yes, so 2. So I'm going to divide a 2 out of both of those. So 6x divided by 2 is 3x. And then divided by 2 on the negative 10 would be negative 5. And then for this one right here, I'm going to go ahead and rewrite that up at this kind of part right here, because I always want to remember that variable first. I want to make sure that I have that in the right order. So I want to put that negative 9x first, and then that positive 15. And when I factor, I want to factor leaving a positive x here, right? So when I factor this out, what will factor out of 9 and 15 is 3, but I want to make sure I take that negative out as well. So I'm going to take out that negative 3. And then that will leave me with a positive 3x and then a negative 5. And then for the denominator, this is trinomial, so there's nothing common right here. So that's our guess and check. So I'm going to set up my two binomials. The only way to get an x squared is x and x. And then I want to look at my factors of 8, right? Factors of positive 8. So I'll just do that off to the side here. So for positive 8, I could do 1 times 8. And 2 times 4. And then in order for me to have a positive 8, these are either both going to be positive or both negative. And I know it's going to be both positive because I have a positive here. And so the factors that will work that will also help me get that 6 in the middle would be 2 and 4. And remember, for any of these, I can distribute that back out and work through that. Okay. All right, and just to kind of verify that factoring. Okay, so then once I do that, so my next step is I want to rewrite that as a single fraction, right? Because we're multiplying. So if we are multiplying, then we can rewrite it and we can put it as a single fraction. So it doesn't mean I'm actually going to do a rewrite. The way I think of it is I think of this is one common fraction. So I'm going to just put a giant fraction bar here. Okay, I could rewrite this if I wanted to, but I need to think of this as one giant fraction, and there is still a multiplier here as well, right? So it's not like subtracting 3, so that is still multiplying. So just for this problem alone, am I going to actually rewrite it? The rest of them I'm not going to, okay? So the 4 and the negative 3 can be rewritten as negative 12, right, because I'm multiplying. And then from there, I'm going to put my grouped binomials, so that would be x plus 2 and 3x minus 5. And again, I don't actually have to do the rewrite, I'm just showing you that it's one single fraction, okay? And then 2 is the only coefficient I have, so it's just going to go out front. And then I'm going to put my grouped binomials next. And then as soon as I rewrite it as a single fraction, and again, from here on out, I'm just going to do like a big old giant line here instead of actually rewriting it. And then I want to divide out any factors that are common, right? So dividing out, meaning one from the numerator, one from the denominator. So from here, I can see that I have an x plus 2 common, and I have a 3x minus 5 common. And I also see that I can reduce the negative 12 and 2, right? So negative 12 divided by 2 would just be negative 6, right? So that would be the only thing left in the numerator. And so then the only thing left in the denominator is that binomial right there, so that would be x plus 4. And I can keep it grouped or not, right? So I can either leave it like this, or if I wanted to, I could go ahead and group it. Okay, so either way. All right. So let's go ahead and try the rest of these. So now you might want to press pause, try the next 4 examples, and see how you fare on that, okay? All right, so completely factor, so that would be my first step. So nothing's going to factor in that fraction, so it's going to stay 3x squared and x plus 2. I'm going to go ahead and group that binomial just because I know that that is a factor, right? So the x plus 2 is the factor, not the 2, not the x. All right, and then in my numerator for this next one, so I have trinomial factoring, which is guess and check. So x squared, of course, would be x and x. And then factors that give me 2, there's only one option, that's 1 times 2, which also will happen to give me that 3. And then, of course, I have that x there. All right, so then as soon as I do that, I think of this as a single fraction, so I'm just going to go ahead and extend that as a single fraction, keeping in mind that these are still multiplying, right? And then instead of rewriting it like I did in the first one, I'm actually just going to go ahead and go straight to step 3, which is to cancel out any common factors. So in the numerator, I have an x plus 2 that will reduce, and then I have this x squared. So keeping in mind that that 3x squared is really just 3 times x, right? Isn't that what 3x squared means? And then I have that x plus 1 grouping, and then I have that x in the denominator. So I could have just reduced the x squared and the x, but I'm just showing you how that's reducing, okay? So again, this is an unnecessary step. I'm just trying to show you what's going to happen with these two guys reducing here, okay? So I know that x divided by x is 1, so that would reduce as well, just like the x plus 2 did. And so then my answer for this one would be 3x and x plus 1, and then over 1, but I don't need to write that down. Okay. All right, and then let's take a look at question number 3. So for this particular problem, there is no factors, right? So there's nothing, no addition, no subtraction, right? So this one right here, there is no adding, and there is no subtracting, right? So if there's no addition, no subtraction, then you are just going to multiply together first. So this step is going to be a little bit different here. So we're just going to multiply together, right? And then that is only, again, because there is no adding and no subtracting. So I'm just going to multiply straight across and create that product. So 4 has nothing to multiply with, so that's going to stay a 4. And then from there, I can go ahead and combine and multiply together the x squared pieces, right? So with that x squared, I have 2 x's being multiplied here, 2 x's being multiplied here, so that would be 4 altogether, so that would be a power of 4, right? So that's when we add our powers, right? So we're adding our powers. And then, of course, there's no other y term, just that y cubed. Okay. All right, and then from here, so now for this next group, so we're going to multiply the 3 with the 6, and that's going to give me 18. And then, so multiplying like variables together, right? And like terms, so to speak. And then I've got x times itself, so that would be x squared. And then finally, I also have y times itself, which is y squared. So again, there's no adding, no subtracting, so this is done a little bit different. So I could write the variables out, like x to the 4th means I have x, 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 and y squared, y, y. But I'm going to go ahead and just use what I know about reducing my terms, okay? So I know with the 4 and the 18, I can divide a 2 out of both of those, right? Wait, can I divide bigger than 2? No. Okay, so I can just divide 2. I had to think about that for a second. So if I divide out that 2, 4 divided by 2 is a 2, and 18 divided by 2 is a 9. And then for the x to the 4th and x squared, right? So then I'm just going to reduce. So I have 4 x's on top, 2 on the bottom, right? So if I have 4 on top, 2 on the bottom, that's going to reduce down to leaving just 2 on top, right? And so if I have 4 on top, 2 on the bottom, so 2 on the bottom are going to cancel away 2 of these, leaving just 2 on top, or x squared. And then, of course, y squared divided by itself would just be 1. And so that would be my answer there, just 2x squared over 9. Okay? All right, well, let's take a look at question number 4. So again, if you have not yet hit pause and you're just listening, this would be an excellent time. Press pause, try to do the last 2, and then hit play forward and check your answers against mine. Okay. So again, there is no addition, no subtraction here, right? No adding, no subtracting. So if there's no adding, no subtracting, then I just multiply straight across and create my new fraction, right? Okay, so let's start with coefficients. So I have a 1 here, a 15 here, so 1 times 15. And then from there, I want to go ahead and combine the variables that are the same, right? So I have an x squared and I have an x cubed. So here I have 2 x's that are being multiplied together with 3 x's. So 2 x's here, 3 x's here. So how many would I have altogether? That would give me 5 altogether. And to show that product, I put it in the power. So that means I have 5 x's being multiplied together. And then here I have 1 y and 2 more here. So 1 here, 2 here. So that would give me 3 altogether, right? So 1, 2, 3. So 3 altogether. Okay. All right, and then let's go ahead and take a look at the denominator. So here I have that 5 and that 2. So, and again, remember we're multiplying, so 5 times 2, so that would be 10. And then now let's gather our x's together. So I have 1 x here and 2 here, right? So 1 here, 2 here, so 1, 2, 3. So I have 3 x's being multiplied all together. And again, when I say I have a product, I always put that in the power, right? Product in the power. So I have 1 x is here, 1 x here, and 2 here. So that would be 1, 2, 3. And then the only grouping of y I have is this one right here. So that would be 4 y's altogether. So y to the 4th. All right, so then let's go ahead and divide. And again, if you haven't press pause, try to finish this problem, and then check it, okay? All right, so between 15 and 10, I can divide a 5 out of both of those. So that's what I'm going to do, divide a 5 out of both. So 15 divided by 5 is 3. And then 10 divided by 5 is 2. And then for my x's, I have 5 x's on top and 3 on the bottom, right? So these 3 x's are going to take 3 of those away. So these 3 will take 3 of those away, and that will leave me with just 2 in the numerator, so x squared. And then for my y's, I have 3 y's on the numerator, 4 y's on the denominator, so 3 here, 4 here. So these 3 on the numerator are going to cancel 3 of those away, leaving just 1 behind. Okay. And I don't need to have that power of 1, right? So that would be, I could also have that option of just 3x squared over just 2y, right? I could have the power of 1 or not, right? Either way. Okay. All right, and then let's go ahead and take a look at the last multiplier. So for this one right here, so I have, what do I have here? So I have factoring I have to do because I have addition and subtraction, right? So welcome back. So more factoring. Okay, so x cubed minus 8, that's that cubic factoring I was reviewing up here, right? So if you're a little rusty on that cubic factoring, maybe go back and check out the chapter 2, I believe it was, and maybe review that if you're a little rusty there. Okay. All right, so x cubed minus 8. So that's a cubic factoring, so I'm going to have a binomial with a trinomial, right? So the cube root of x cubed is x, the cube root of 8 is 2, and I want the sign to stay the same, right? So the sign to stay the same. And I'm going to square, multiply, and square my roots. So square, so x times itself. And then I want to multiply those two together, so x times 2 is 2x, but I want my sign to be opposite, right? And then square the second root, so 2 times 2 is 4, and this will always be positive. Okay. And then for this guy here, I'm going to go ahead and put that in the correct order, so that would be negative x squared plus 4, right? Always have that in the correct order before you start to factor. And then over here, I'm going to do guess and check, right, because I have a trinomial, 1, 2, 3. So for that, I'm going to, let's see, so 2 binomials. So x squared would be x and x, and then my factors of 6 are 1 and 6. Let me go upside down here. So 1 and 6 or 2 and 3. And they can either both be positive or both be negative, right? So in this case, they're going to both be positive because that middle term here is a 5x. So which of these will combine to help me get that 5? And that would be 2 and 3, right? So 2 and 3. So that would be x plus 2 and x plus 3. And then down here, I'm going to, let's see, what can I do here? I can factor out an x, right? So GCF. So if I divide an x out of both of those, I would get x plus 3. Okay. So I'm not done factoring, right? Because I can certainly factor this, and I can keep going. But I'm going to treat this now as one fraction, right? So just to save a little bit of rewrite, I know I can certainly cancel the x plus 3, so I'm going to go ahead and do that. And then I'm going to keep factoring on this, though, right? So I can take a negative out of there. So let me rewrite the top, though. So I have x minus 2 plus 2x plus 4 and an x plus 2. I'm going to take a negative out of that, so that will give me x squared minus 4, and then I still have that x there, right? So if I look, I don't have anything I can reduce any further, but this will factor one more time, right? And that will factor to a difference of squares, So rewrite the top. I know that's really tedious, all this rewriting. And some of you who are really good at factoring, maybe you are already finished. But I am going to rewrite. Okay, so difference of 2 squares. So this would be, the negative is still there, it doesn't go away. And then I have x plus 2 and x minus 2, and then I also have that x there. So then I can cancel actually quite a bit more, right? So the x plus 2's will cancel, as will the x minus 2. And so then I'm left with, in the numerator, x squared plus 2x plus 4, and then in the denominator that negative x. And typically we like to have the negative sign in the numerator, so I'm just going to move it up to the top. But it would not have been wrong if you had written this as negative x. Okay? All right, so that is the multiplying. So now the dividing really is same-o, okay? So for the dividing component, the only thing that we have to remember is when we are dividing, we multiply by that second fraction, right? So we switch it from a division to a product, right? So division to a product. And so in order for us to do that, we have to do the multiply by the second value, right? Or the reciprocal of the second term. Okay, so when we work with c over d from division, we multiply by the reciprocal, so d over c. Okay, and then, so it really is exactly the same as the front side, just with that one extra step. So if you feel pretty good about that, then you should be fine. And we are not doing complex fractions, which is number 5. So I'm going to cross number 5 off because, again, that's a complex fraction and we're not doing that piece of it. Okay? We forgot to edit that from the notes. Or I'll take credit for that one. I forgot to make that edit. Okay, so let's go ahead and take a look at question number 1. So again, like, this does not go away. Factor, people. We need to factor it. We'll switch the division to a multiply problem, and then we'll do a rewrite, so to speak, right? And then we will divide out our common factors, okay? All right, so we're going to factor. So I have x squared minus 25, so that's a difference of squares, so that would be x plus 5 and x minus 5. And then all over, and then for this one here, I can divide a 4 out of both of those. So GCF. I'm going to switch this to division, or switch it from division, sorry, to multiplying. But then when I do that, I need to make sure that the second fraction, I write the reciprocal. Okay, so I'm going to write the reciprocal of the second fraction. Okay, so then x minus 5 becomes my denominator, and nothing factors out of that. So I'm just going to group it so I can see it as a binomial. And then this is a trinomial, so that would be our guess and check. So that would be x and x. And then my factors for 14 are 1 and 14, 2 and 7. So I would use 2 and 7 because I'm trying to get that 9 and both positive. Okay. And then I rewrite that as a single fraction, but not actually rewrite it. So I'm just going to make that an extended division bar. So I'm thinking of this as one big giant fraction, right? So those are still products up there. Kind of makes it look like a division because I got that extra line there. Okay, so then now I look for common factors to reduce. So I have the x plus 7, and then I have the x minus 5, and that looks like it. So then my answer, so the only thing left in the numerator is x plus 5 and x plus 2. And then the only thing left in the denominator is that 4. And that would be my answer, okay? So this would be a great time to press pause and try those last 3 problems on your own and kind of see how you fare on that, okay? All right, so for number 2, so we have our first fraction, so y plus 4, that nothing's going to factor out of that, so I'm just going to group it. And then for that denominator, so I have a trinomial, so I'm going to do guess and check. Y squared, so that would be, both would be y. And then my factors of 6 are 1 and 6 or 2 and 3. So 1 and 6 or 2 and 3. So in order to get that positive 6, they're either both positive or both negative. In this case, both positive, right? So that means it's going to have to be the 2 and the 3. So 2 and 3. And then again, we're going to switch that division to multiplication. And then we can do that only if we do the reciprocal of the second, right? So this is now going to become the denominator. So I can factor, so this is GCF, so I can factor a 3y out of both. So that would be leave a y behind and a plus 4. Okay. And then the denominator is going to be guess and check. So to get a 2y squared, I have to use 2y and y. And then the only way to get a negative 3 is 3 and 1, but one of them has to be negative, right? So guess and check, but I'm going to have to check this time because of that 2 here, right? So I'm going to try 3 and 1. So when I check that, I would get 6y and 1y, which will subtract to 5y if the 1 was negative. And one of them has to be negative, right? So I know that's the way it's got to work. Okay. And then I think of this as a single fraction, so I'm just going to kind of extend that line there. And then I look for my common factors to reduce. So y plus 4 cancels, y plus 3 cancels, and that is it. So I'm left in the numerator with 2y minus 1. And then in the denominator, I'm going to put this in the right order, right? So I have these two guys here. And I know this one is right now first, but what should be first is that 3y. So that 3y is really what I should have first. Right? And that's just for, not because it has to, it's just like kind of that standard form. Okay. All right, and then let's take a look at question 3 and 4. So the last two here. So for question number 3, we have no adding, no subtracting. So I'm just going to go straight into that multiply by the reciprocal. So I have, because there's no factoring to be done, right? So I have x squared and I have 3xy. switch that to multiplication, but I can only do that if I do the reciprocal of the second fraction. And so once again, I'm going to go ahead and multiply straight across to simplify this out, right? So I have, and some people like to cancel first, okay? So I know on the front side I like multiplied everything out, but some people like to cancel first, which is way okay. But if you do that, you need to remember that that 6 is separate from the x and the y, right? These are separate from each other. They're not like, even though it's 6xy, it's 6 times x times y. So I'm going to cancel first on this just so that you can see it as an alternative way to do it. So the x squareds will reduce, right, because those are the same, and then x will reduce, as will y. Okay. And then I can also reduce that 6 and the 3 as well, right? So I could do 6 divided by 3, so I can take those and divide them. And so when I do that, it would leave me with a 2 in the numerator. So that would go, right? And that would become a 2. And then the only thing left in the denominator is that y squared. Okay. All right, very last problem here, question number 4. And so for this particular problem, we're back to that factoring piece. So if you have not pressed pause on the back side, press pause, try 4, hit play, and then check your answer against my answer. Okay? All right, the last one here. So we're going to factor the numerator. So I'm looking for guess and check because I have that trinomial there. So factors for y squared are y and y. And then my factors for 8 are 1 and 8 and 2 and 4. And they're both positive, right? Because this is positive. So 1 and 8, 2 and 4. And so that would be 2 and 4. And then for my denominator, and again, if you're rusty on your factoring, go back and watch a factoring video, okay? All right, so y squared would be y and y. And then factors of 2 are 1 and 2. And so then I need to have that positive here but negative here. So I want my 2 to be positive, my y to be negative, right? So that would be negative 1 times 2 is negative 2, but negative 1 times 2 is positive 1, so that'll work. And then switch that division to a multiply, and then at the same time make sure you flip-flop your second fraction because you're dividing, switching to multiply by the reciprocal. So that numerator now becomes a denominator, and that doesn't factor, so I'm going to go ahead and group it. And then this now, the denominator becomes a numerator. And I could do GCF here, so I can factor a 2 out of both of those, and so that would leave me with y plus 2. Okay. And then I think of this again as a single fraction, right, being multiplied together. And so now I look for common factors. So I have a y plus 4 that is common, and a y plus 2. And so then the only thing left in the numerator is y plus 2 and 2. But again, I want to make sure I'm in the right order, so that 2 should actually be first, right? And then the group of y plus 2. And then in the denominator, the only thing left is y minus 1. And I can leave it like that, or I can group it. Both are okay, right? So it doesn't matter if I have the denominator grouped or not, right? Both are fine. And that's it for this lesson.